Hello and welcome. I want to talk today about gravity and particularly about whether gravity or density explain things that we observe. So the question is, can the effects that science puts down to gravity be explained only in terms of density and or buoyancy? And I want to look at one particular observation or example. The observation is an apple falls from a tree. This is the famous observation attributed to Isaac Newton that allegedly gave birth to his universal theory of gravitation. How does Newton's theory explain this? Well, Newton's theory of universal gravitation states that all objects that have mass are attracted to each other. He further states that this attraction is proportional to the masses of the object and inversely proportional to the square of the distance between them. This means that all objects that have mass in the universe are always being simultaneously attracted to all other objects in the universe. It's a common misconception to think that the Earth exerts a gravitational force on the apple. It does not. Both the apple and the Earth are attracted to each other all the time. So if both objects attract each other, why does the apple move towards the Earth or the ground instead of both the Earth and the apple moving towards each other? The complete answer to this question is complicated because there are many forces involved and many properties of matter involved. A simple answer is that it takes a lot more force to move the Earth than it does to move the apple. We know from experimentation that force equals mass times acceleration. So if the mass of an object is large and a small force x is applied, then the acceleration will be tiny. By contrast, if the mass of the object is small and the same force x is applied, then the acceleration will be much greater. So a force of 10 newtons acting on a mass of 1 kilogram will cause an acceleration of 10 meters per second squared. By contrast, a force of 10 newtons acting on a mass of 1 billion kilograms will cause acceleration of 0.000000001 meters per second. So the effect of the force of attraction between the apple and the Earth will be that the apple accelerates towards the Earth much faster than the Earth accelerates towards the apple. Newton's theory of gravity certainly explains the motion of the apple once its link to the tree is broken. But does it explain why the apple falls at a specific time? The apple has been on the tree for some weeks before it falls. Why doesn't it fall earlier? The simple answer is because it's attached to the tree. Even so, we must now add the following to our theory. The apple stalk is strong enough to hold the apple to the tree, overcoming the force of attraction between the apple and the Earth. At some point, the stalk must become too weak to overcome the force of gravity, and so the stalk breaks and the apple falls. Well, it seems that Newton's theory of gravity explains the falling apple quite well, and there are equations that can be used to calculate the extent of gravitational attraction between two objects, as long as we know their mass and the distance between them. One thing that the theory of universal gravitation cannot do is explain the mechanism that generates the force, or the means by which its effect is transmitted. If I kick a ball, it moves because the force of the movement of my foot is transferred to the ball by physical contact. If the theory of gravity is correct, then the force of gravity acts at a distance with no physical contact between the objects. So far, scientists have not been able to explain how this happens. Much the same way, they cannot explain how the force of magnetism is able to act at a distance, either repelling or attracting other magnets, or attracting magnetic materials. However, this doesn't mean that the theory of gravity must be wrong. The fact that we can't explain how it works doesn't mean it doesn't exist. And hopefully one day scientists will show exactly how gravity works and maybe how magnetism works as well. But at the moment, we don't know. And that's absolutely fine to say we don't know how it works. Okay, so how would density and buoyancy explain the apple observation? Well, no scientist has ever tried to explain the apple dropping in terms of density and buoyancy, but I will have a go. It's worth pointing out that flat earthers do not attempt to explain such things either. They simply say that everything science explains by gravity can also be explained by density and buoyancy, and simply leave it at that. Okay, so we observe the apple falling to the ground. To explain this in terms of density, we can say that the apple is more dense than the air that surrounds it. That's easy to check, and it's true, so far so good. So now we need to have a rule that when the object is more dense than the medium that surrounds it, it will pass through that medium. Okay, so far so good again. However, there is a problem. The air above the apple is less dense than the apple. The air to the left is also less dense than the apple, and so is the air to the right. In fact, the air surrounding the apple is all the same density and is all less dense than the apple. So why does the apple always fall towards the ground instead of away from the ground or parallel to the ground? If the relative densities of the air and the apple were the only things in play, then why does the apple only move in one direction? We're going to need another rule, and that rule needs to state that an object that is more dense than its surroundings will always move towards the ground. So, do we have a better theory? And our theory now states that an object that is more dense than the air that surrounds it will always move towards the ground, and we can even measure how quickly objects move towards the ground and do some experiments to check whether the theory holds true. Seems okay. However, our new rule has created a problem because it's introduced something new into the theory, and that something new is the ground or the earth. We are now invoking a sense of direction. What is it that causes the apple to follow this sense of direction? In short, our new rule is simply restating the observation that the apple moves towards the ground. The rule has not explained anything. At least the theory of gravity stated that there was a force that caused the movement, and the measurable properties of that force, proportional to mass and inversely proportional to the square of the distance, explained the direction of the observed movement. Then there is the issue of the apple stalk. The stalk does get weaker as the apple ripens. I won't bore you with the biology, but the stalk doesn't disappear before the apple falls. We know it gets weaker, but the apple falls at a time when its mass gets to a point that the stalk is too weak to hold it any longer. So we must assume that there is a force acting upon the apple all the time. The stalk is strong enough to overcome this force, but the stalk is gradually getting weaker and weaker, and the apple is gradually getting bigger and bigger. Eventually there comes a point at which the strength of the stalk is less than the force acting upon the apple, and the apple falls to the ground. Okay, that's fine. But what is the force? The force cannot be due to the density of the apple and the density of the air. If it was, there'd be no reason for the apple to move towards the ground instead of moving away from the ground or parallel to the ground. Okay, we have no choice but to say there is a force that makes the apple fall towards the ground instead of away from or parallel to the ground. Yeah, that works. I'll call it the falling force, and I'll say this falling force is always acting towards the ground. So we have an apple that is more dense than the air, and a falling force makes the apple move towards the ground once the falling force becomes stronger than the stalk that's holding the apple to the tree. Fantastic! I've just explained the falling apple in terms of density. But wait a moment. How is the falling force any different from gravity? Well, it's far less well explained. I haven't said anything about the falling force except that it's needed to explain why the apple moves towards the ground. Apart from being rather badly described, isn't the falling force doing just the same job as gravity? Okay, I can explain the apple always falling towards the ground. Sorry, can I explain the apple always falling towards the ground without using a falling force? Yeah, no. Wait, yes, I got it. No, sorry, I haven't. No, sorry. I can't explain why the apple falls without invoking some sort of force to make it happen. Please, can someone help me? And any flat earthers out there, explain why the apple falls towards the ground without invoking a force that makes it do so. Density doesn't explain that. It just doesn't. So there is the problem. Density is all very well, but it cannot explain why the apple falls to the ground without invoking some sort of force. As soon as a force is invoked, it will turn out to be similar in all respects to gravity. You see, gravity really does help describe exactly what we observe in the real world. So, can anyone living in the flat Earth universe please explain to me how density can explain the falling apple without invoking a force? If you can't do that, I'd settle for someone explaining it using a force that is different to gravity in anything but name. Thank you, but I fear that I will have a very long wait.